Good morning. I am Neeraj. Today we'll learn about calculation of reinforcement for beams. I have already drawn one longitudinal section and cross section of a beam. The cross section of beam is 250 mm by 400 mm. The clear span of beam is 4 meter. It is resting over a support of 300 mm on the both side. About the reinforcement, there are two number 16 mm dia steel bar in bottom, two number 12 mm dia bar on top fiber. Then there are two number 10 mm dia cranked, we can say bent up bar, and again there are stirrups which is of 8 mm dia at 190 mm center to center. So we are taking out the quantity of reinforcement for mild steel. That's why I have given this hooks. The value of this hooks for mild steel is 9.5. So if there is a reinforcement of length L and there are two hooks, one hook here and one hook here, then total distance will be, or total length will be L plus 9.5 plus 9.5, which is equal to L plus 18.5, right? This is only for mild steel. If it is a Tor steel, or we call as Fe415, then instead of this hooks we'll have L's. Since Tor steel cannot be fabricated into the hooks, we can just make a hooks by 90 degree. Okay. Now again crank. As we are considering two numbers 10 mm dia crank, then what will be the length of a crank? Let us assume the crank is making an angle of 45 degree with vertical and horizontal both. Okay. So this is a crank which is making angle 45 degree with the bottom. Let us assume a distance from this top reinforcement to this bottom reinforcement as D. Then we can calculate this side X by sine 45 degree is equal to perpendicular, which is D, and the hypotenuse, which is X. So X can be calculated as D divided by sine 45 degree. Since we have 45 degree angle, so base will be of D. Now X will be equal to 1 divided by sine 45, which is 1.414D. So the increment length will be length of crank, or we can say extra length for crank will be equal to 1.414D minus D, which is equal to 414D. On the higher side, we round off as 0.45D. So for two number crank, one for this crank and one for this crank, we'll multiply this figure by 2. Then we'll get 0.9D, which can be taken approximately as D. So for two cranks, we'll add one depth of the section, or one depth, the distance between the top bar and the bottom bar. So first of all, we'll calculate the bottom bar. You have to make this table, serial number, then second column will be the particular, then dia, the number of bar, length in meter, then weight per meter, then the quantity can be calculated by numbers multiply length multiply weight per meter, we'll get the quantity in kg. Now coming to the calculation of reinforcement. See, particular one will be, we are calculating the quantity of 16 mm dia steel. So bottom bar, which is two numbers 16 torr. You have to write here 16 as a dia. Now numbers already shown in the figure, we have two numbers, so this is 2. Now length will be the outer to outer length of this beam, then minus cover from the right side, then cover from the left side, and two hooks. Okay, so we'll have the length 400 mm clear distance. Now adding 300 mm for this support and 300 mm for the another support, so we'll have 400 plus 300 plus 300 minus 2 covers of the beam. We are assuming the cover of beam to be 25 mm. So minus 2 side covers and plus 2 hooks. One hook to the left of the beam and one hook to the right of the beam. So plus 2 hooks. Okay. So length can be calculated as 4000 plus 300 minus 2 cover, which we are taking 25 mm, then 2 into 25 plus 2 hooks. So for 2 hooks we take 18.5, 9.5 for each hooks. So 18.5, 5 will be the dia of the bar, considered bar. So dia is 16. So 16 into 18. 2 hooks can be calculated as 18.5. Just remember this. Okay. So length will be, just use calculator for that, 4000 plus 300 minus 2 into 25, then plus 18 into 16, which comes out to be 4838 mm, or we can say 4.83 meter. You have to write the length 4.83 meter. Now the weight per meter of 16 mm dia bar can be calculated by a simple formula, d square divided by 162, where d is the diameter of the bar. So for 16 mm dia bar, we will calculate 16 into 16 divided by 162, which comes out to be 1.58 kg per meter. 1.58 kg per meter. You have to write here 1.58 kg. Now to calculate the total quantity of reinforcement, we will multiply 2 to the length to the weight per meter of particular bar, we will get the total quantity. So 2 multiplied by 4.83 multiplied by 1.58, which is 15.26 kg. 15.26 kg. Right? Now, calculating the top bars, serial number 2, top bars. So we have a top bars of 2 numbers, 12 dia straight. Straight means it is through along the beam. So we'll write here 12 dia. The numbers are 2, already shown in the figure. So we'll write here 2. The length can be calculated in the similar fashion, which is, just I am rubbing, and we'll calculate the length of top bar. The only change will be of hook. So 4000 plus 300 plus 300 for support, then minus 2 side covers are same, plus 2 hooks. Now this time the phi will change. In this case phi will be 12. Okay? So we will write 4000 plus 300 plus 300 minus 2 into 25 plus 2 hooks. Now 2 is constant. The value of hook will be 18.5. So we will write here 18 into 5 will be this time 12 mm. So 12. On calculating this, 4000 plus 300 plus 300 minus 2 into 25 plus 18 into 12. You will get 4.766. 4.766 meter after converting from mm. So this time you have to write here 4.766 meter. Again, the weight per meter can be calculated for 12 mm dia by a simple formula, which is d square divided by 162, means 12 into 12 divided by 162, you will get 0.89 kg per meter. Right? So you have to write here 0.89. Now the total quantity can be calculated by multiplying the number to the length to the weight per meter. We will multiply this into this into this. We will get 2 into 4.766 into 0.89, which is equal to 8.48 kg. Now coming to the crank, there are 2 cranks of 10 mm dia. Now our third item will be cranked bar. Okay? Cranked bar of dia 10 mm. So we will write here 10 mm. Numbers are 2. Correct? Now the length can be calculated in the same fashion. The only difference will be we have to add the length for cranked portion. So I am just modifying for 10 mm. Now we will calculate the length of crank bar. Distance will be 4000, clear distance 4000, we'll add support of 300 plus 300. There will be two side cover, there will be two hooks. Apart from that, we'll have to add plus two numbers cranked. So here 4000 is okay, 3000 is okay. Two side cover which is of 25 mm each, two hooks. Now this time the dia for hooks will be 10 mm. So we'll multiply 18 mm by this 10 mm. Okay? And apart from that, we'll add the length increment for two crank, which is D. We have already seen previously that for two crank we'll add the length of D. What is D? I have already marked a section AA. Here is a section of AA. This is a crank portion. We'll calculate the length here. These are the crank. These are the cranked. So we'll calculate the center to center distance of the crank. Now this is crank and here will be the crank. Okay? So this distance will be calculated as 400 minus top cover minus bottom cover, which is 25 for top cover, 25 for bottom cover. Then there is a ring of 8 mm. Just see 8 mm dia at 190 mm center to center. Then you have to subtract 8 mm for top ring and 8 mm for bottom ring. Okay? Now you have to subtract half the dia of cranked bar, which is dia of crank bar is 10 mm. So we will deduct 5 mm for top and 5 mm for bottom, which minus 5 minus 5. You will get the depth which has to be added in the length for cranked portion. So 400 minus 25 minus 25 minus 8 minus 8 minus 5 minus 5. You will get 324 mm. 324 mm. So this 324 mm shall be added in the length for crank. So length of the cranked bar will be 4000 mm plus 300 minus cover, which is 2 into 25, then 18.5, the 5 will be taken as 10 mm, plus the depth which has to be added, which is 324 mm. So you have to just increase 324 mm for making two cranked. So the length will be, we have to calculate now 4000 plus 300 plus 300 minus 2 covers means 2 into 25 plus 18 into 10, then plus 324, which comes out to be 5054 mm. 5054 mm or 5.05 meter. So length of the cranked bar with 2 number crank will be 5.05. Correct? The weight per meter for this 10 mm dia can be calculated by the same formula, which is d square by 162 means 10 into 10 divided by 162. It comes out to be 0.617. We are rounding off 0.62 kg per meter. You have to write here 0.62. Just multiply these three quantities, you will get the quantity of steel for cranked bar. So 2 into 5.05 into 0.62. You will get 6.26 kg. 6.26 kg. Fine. Now we have to calculate the quantity of stirrups, right? I have drawn a simple cross section of a beam, of this particular beam, in which I have enlarged the view. So if you see the section, these are the two bars. This is 12 mm dia. These are the two numbers of bar which are having the dia of 12 mm. These two bars having the dia of 16 mm. Just I am writing here only 16 mm, and this is 12 mm, and these are the crank portion of 10 mm dia. Now the stirrups is of 8 mm dia. These are stirrups, right? These are of 8 mm dia. Now there are hooks of 75 mm each. 75 mm hook. So our fourth item will be stirrups, or you can call as a shear reinforcement. In the figure we have given a stirrup of 8 mm dia at 190 mm center to center. So 8 mm dia at 190 mm center to center. In this dia column you just write 8. Now numbers will calculate in the next step. First we will calculate the length of stirrups. So how will you calculate the length? See, this is a section. You have to calculate the center to center distance of this stirrup, okay, and center to center distance of this stirrup. You will get the perimeter, then adding the total perimeter plus two numbers of hook will get the total length of the stirrups. Okay, now calculate. This length we have to calculate for calculating the stirrups. Now the total depth of the beam is 400. Just write here 400 minus 2 covers, the top cover and bottom cover, minus 2 covers. For beam we take cover as a 25 mm. So 400 minus 2 covers, then minus half of the dia of stirrup, which is 4 mm, and half of the dia of stirrup, which is 4 mm. So deducting 8 mm from this length, we'll get 400 minus 2 covers. 2 covers are 400 minus 2 into 25 minus 8. You'll get 400 minus 2 into 25 minus 8. 342 mm. 342 mm. Similarly, we'll calculate this particular distance. This distance will be 250 mm minus 2 covers, 2 side covers, which are 25 mm each, means minus 50, and minus half the dia of this stirrup and half the dia of this stirrup, which is 8. So you will get 250 minus 50 minus 8, which is 192 mm. So the length can be calculated. Length of stirrups can be calculated as the perimeter of this strap plus 2 hooks which we have taken as 75 mm each. Now 2 times of 342 plus 192 mm plus 2 hooks. Now here we have hooks of 75 mm. So 2 times of 342 plus 192 plus 75 and one more 75. We'll get the length of strap 342 plus 192 into 2 plus 75 plus 75, 1.218 meter. You have to write this length here. This is 1.218 meter. Now number of straps can be calculated by number of straps will be the total length of the beam, which is 4 meter plus 0.3 meter plus 0.3 meter, or we can say 4.6 meter outer to outer minus 2 covers divided by the spacing plus 1. So number of straps will be 4000 plus 300 plus 300 minus 2 covers. This has to be divided by spacing, which is 190 mm, and this whole quantity is added by 1 to get the total number of straps. So 4000 plus 300 plus 300, it is 4600 minus 2 cover, the cover of the beam are 25 mm each. So 25 into 2 is 50. This quantity to be divided by spacing, which in our case is 190 mm center to center, and the total quantity is increased by 1. We'll get the number of straps. So 4600 minus 50 divided by 190 plus 1, which is 24.94. 24.94. Rounding on the higher side, we'll take 25 numbers of straps in this particular beam, which is at the spacing of 190 mm center to center. So there will be 25 number of straps. The quantity of strap can be calculated by 25 into 1.218 and the weight per meter, which can be calculated by the simple formula, which is d square divided by 162. In this case, the d will be 8 mm. So 8 into 8, which is 64, divided by 162, will get 64 divided by 162, which is 0.39, which is 0.39 kg per meter. So weight per meter for 8 mm dia will be 0.39. The total quantity can be calculated by multiplying the number to the length to the weight per meter, which will be 25 into 1.218 into 0.39. You will get the quantity of 11.87 kg. This is your answer. Okay, got it?